Okay, so Pablo is running a half marathon at a velocity of 3 meters per second. Another runner, Jacob, is 50 meters behind Pablo with the same velocity. Jacob begins to accelerate at 0.05 meters per second squared. How long does it take Jacob to catch Pablo? What is the distance covered by Jacob? And what is the final velocity of Jacob? And so the first thing you want to do is we're just going to write the givens, and I'll do that. I'll just pause this. Okay, so we have the initial velocity of Pablo is 3 meters per second, and then his velocity is implied to never change because it gives us Jacob's acceleration, and it says that he begins to accelerate while he's running the same velocity as Pablo, and because we never get an acceleration for Pablo, and it just says he's running half marathon at a velocity of 3 meters per second, we're to assume that the velocity is constant for Pablo, which means that his acceleration will be 0. So Pablo's initial velocity is 3 meters per second. His final velocity would be 3 meters per second because it's constant. And then because his acceleration is the rate of change of velocity and his velocity doesn't change, it's going to be 0 for his acceleration. Now, Pablo's initial position, it can kind of be like, there's a lot of different ways to do it. I think the simplest way is to just make Jacob at 0 right here and Pablo, because it says Jacob is 50 meters behind Pablo. So just make Pablo at like positive 50. You could make Jacob at negative 50 and Pablo at 0, but I don't know why you would do that. And you could also, I guess, make Jacob at 25 and Pablo at 75, but don't. um, but anyway. So Pablo's initial position is 50 meters per second, and Jacob's initial position is 0. And then Jacob's initial velocity is 3 meters per second because it says that he starts running at the same velocity as Pablo. And then he says that he begins to accelerate at 0.05 meters per second squared. So that's Jacob's acceleration is going to be 0.05 meters per second squared. So now what we're solving for this first part of the question is how long does it take Jacob to catch Pablo? So we want to know at what time do Jacob and Pablo basically have the same position? Because when Jacob passes Pablo, at that instant they're gonna be at the same position, and then Jacob's gonna pass him. So we need to know what time that happens. So we look at the equations that we have, the formulas that we have, and you just look at like what applies to the situation. Because we're doing it so that Jacob and Pablo have the same position, and we're solving for time, and also because of the variables that we're given, or the values that we're given, I think it makes the most sense to use this equation, because this is literally an equation for position, so we can set these two equal to each other for Pablo and Jacob. So we want x final for Jacob to equal x final for Pablo. Okay, hang on. There we go. And so it would be, I think it's x initial plus v initial times t plus 1/2 at squared. Yes, okay. So x initial for Jacob, which is 0, so we're not going to put it, but x initial for Jacob would be 0 plus v initial for Jacob, or times t plus 1/2 times the acceleration of Jacob times t squared equals x initial for Pablo, which is 50. It's not 0, so we have to make sure we include that, plus v initial for Pablo times t, and then the acceleration for Pablo is 0, and that would make this whole term 0 because it's being multiplied by acceleration. So we're not going to write it. It's just 0. And so now you basically just want to solve for t. So first you're gonna want to do is you're gonna want to plug the numbers in so that you can do algebra with them. So first of all, the initial velocity of Jacob is 3 meters per second times t plus 1/2 times Jacob's acceleration is 0.05 meters per second. 0.05 meters per second squared. I forgot to say squared. Times t squared. And that's going to equal Pablo's initial position, which is 50 meters plus the initial velocity for Pablo, which is 3 meters per second, times t. So originally I thought we were going to have to do quadratic formula for this, but you just subtract the 3 meters per second from both sides, times t, and then these two cancel out, so you're just left with the only t left being the t squared here, which means you don't have to do quadratic formula. It's very convenient. Oh, actually, 1/2 times 0.05, 0.025, so we'll just write that. Meters per second squared. No, wait, let me get rid of the 1/2. Okay. All right. Okay. I wish I didn't do that. Okay. There we go. Meters per second squared. And then times t squared equals 50 meters. And then you just divide both sides by 0.025 meters per second squared. And then you take the square root of both sides because of the squared here, and then you would have t equals square root of 50 meters divided by 0.025 meters per second squared. And something that I like to do I'll keep my units when I'm doing physics problems, which I think you might be supposed to do that. I'm not 100% sure, but keeping the units lets you tell if you did the problem right a lot of the time, because, or at least the algebra part of it, because if you come out with the correct units, like we're solving for time, so we need seconds or whatever, any time unit really, but we need seconds in this instance. Then you know your answer is probably right. And the meters here would cancel out, and then the s squared would go on top here. And then because it's under a square root, it would just become an s. And so we know that it's in seconds, so that reinforces my confidence in this answer. And then if you get... okay. Okay. Oh. We get 44.721 seconds. And if we check the answer for A, yeah, 44.7. No, never mind. I was going to say they actually do significant digits, but no, they don't. No, they don't. That's an extra one. Okay. So the next question is, what is the distance covered by Jacob? So here, let me think that over real quick. So what we want to know is the distance covered by Jacob when he passes Pablo. And because Jacob is starting at 0 for us, this will be easy to find, because it's basically just like the change in x, which is going to equal x final minus x initial. And because x initial is 0, it's just gonna equal x final. But anyway, to do this, the easiest way to do this is we already solved for t, so we have t equals 44.7 seconds, and then we just look at the equation here. X final equals x initial plus v initial times t plus 1/2 at squared, and we have change in x for Jacob. It's just gonna equal x final for Jacob minus Jacob's x initial, and then we have to solve for x final. So x final for Jacob is gonna be his initial position, which is 0, so we're not gonna write it, times v initial times t, which is 44.7 seconds. Then plus 1/2 times a, which is 0.05 meters per second squared, times t squared, so 44.7 seconds squared. And now we just multiply, or now we just plug it into a calculator. There's no there is multiplying, but we don't do that. The calculator does that. So 3. I'll just do it off camera. And that should equal. Okay, that's not. That should equal 184.05 meters, and then also meters per second times seconds is a meter is meters, and then meters second squared times seconds squared is also meters, so we know the unit is in meters. Not that it really matters because we're just plugging stuff into a formula. I don't see how I could have fucked that up, but you know. Anyway, 184.0, yeah, okay. Although that should have rounded to 184.1, but that's fine. I don't care. So the next part of the question is, what is the final velocity of Jacob? And here, let me think this over real quick. So we're just trying to find the final velocity of Jacob. We have the time now and the final position. So we just need v j final, and there's a formula for this. It's just v initial plus at, and because we have t now, we can just plug numbers into that. So so v final is gonna equal, why? Okay, and that's gonna equal vj initial plus the acceleration times t. Yeah, okay. And then we just plug it in, so it's gonna equal 3 meters per second plus 0.05 meters per second squared times 44.7 seconds. So times 44.7 seconds. And then you can also just see the units are right, but again, we're plugging stuff into a formula, so you know it's not really hard. It's kind of hard to fuck up, but you know, I mean, I make stupid mistakes all the time. So anyway, 3 plus 44.7 times 0.05, and that is 0.235 meters per second. And that should be the final velocity of Jacob. And so, yeah, 5.24. Okay, why did they round it that time? Whatever, man. All right, that's how you do this one. All right. If you need help with anything else, let me know. If you need this to be explained differently, let me know. Yeah. I guess actually you really only needed part A. I didn't realize part B and C were just kind of plugging stuff in, but yeah, it's good. It's good to have in case. Anyway, let me know if you need anything. Goodbye.